Okay, so now what we're going to do is we're going to talk about linear and angular speed. Okay, so this comes handy in physics and it's very important to understand. So if you look at this example here, let's say you've got this wheel, right? Let's say a bike wheel, right? And so you're looking at the spokes on one of the bike wheels. And let's say you put a dot on the, mark it with some chalk and on the tire. And so we can talk about linear velocity or linear speed like this. Because remember, if I look at a car, right, linear speed, distance equals rate times time, right? So the rate, the speed of the vehicle is just R equals distance divided by time, right? That's easy, that's intuitive, right? It's how fast you go, how far you go over a certain amount of time. That's your speed, right? Well, in this situation where we're looking at rotations of pulleys or gears or bike wheels, the distance traveled, right, d, is the arc length, right? So the chalk mark is going to go from here to here, let's say. And so how fast it moves from here to here. So the distance is the arc length. So that's the linear part. So it's the displacement, right? Or the arc length is what I like to call it. So in this case, we would say the velocity or the linear speed, v, is equal to the arc length over time. Okay? That's how we represent linear speed. Okay? Now, angular speed is, think about the term, angular. It's how fast it's moving, how fast the angle is changing over unit time. Okay? So if I go from here to here, let me draw it this way. Right? And now I'm going oops, that's bad. I don't like that. Okay? So now what happened is going from here to here, I've covered a certain angle, right? So now that's angular speed. Now that's different than linear speed, right? So linear speed is about the arc length, how fast you're covering the arc length per unit time. So for angular speed, it's how fast the angle is changing over per unit of time. Okay? So how do we develop or derive the angular momentum? Well, it's just given by omega. So angular momentum is given by this. It's omega is equal to the central angle, the change in the central angle over time. So that's angular momentum, or not momentum, did I say momentum? Angular speed. Okay? So this is angular speed and this is linear speed. Okay? Okay, so now, if we combine both of those definitions, okay, so the definition of angular speed and arc length, then what we can do is we can find a relationship between angular and linear speeds. Okay, so let's do that. So if I know that S is equal to theta times R, right? And so now what I can do is what? use this to plug in, substitute in for theta. So this tells me that theta is equal to omega times t. And so then I can combine that by substitution, and so I get S is equal to omega times time times the radius. Now, if I substitute this in to the linear speed, right now, look at that. Now, guess what? Now I can take this and I can substitute it into here, and I've got it. So now, this becomes what? V is equal to, well, S is this, so it's omega t times r divided by t, and look at that. Now I get my final result, a formula that relates linear speed to angular speed, and it's V is equal to omega r. And there we go. And so those are the things you want to remember. So this is one formula. This is another formula, right? And then those three formulas. Okay, we'll be back and we'll do some examples. Have a great day.